Welcome back to the Deep Dive. Today we are really cracking open some essential infrastructure, stuff that defines secure digital finance.
Yeah.
Our mission is a deep dive into Chainlink. We're looking at its core technology, these decentralized oracles, and also the big strategic shift that's Chainlink 2.0.
And it's really critical territory because look, blockchains are great. They're secure, decentralized, fantastic.
Right.
But they're kind of stuck inside their own bubble. They're inherently inflexible. A smart contract sitting on its chain, it just can't securely grab the dynamic real-world data it often needs.
Like what sort of data are we talking about?
Oh, stock prices, weather updates, API results, event outcomes, anything happening off the chain.
And trying to get that data in directly is the problem.
Doing that usually means sacrificing the very security and decentralization that makes the blockchain valuable in the first place. You introduce a weak link.
So the problem is basically, how do you talk to the outside world without opening the fortress gates to some central point of failure?
Yeah, precisely. And that is the exact gap Chainlink aims to fill. They use what they call a Decentralized Oracle Network, or a DAWN.
Okay, a DAWN.
Yeah. So instead of just trusting one single data feed, which could be wrong or manipulated or just fail, a DAWN gets a whole group of independent nodes together.
Oh, okay.
These nodes fetch the data from the real world, they compute it, aggregate it, verify it, check its integrity, and then securely deliver the result to the smart contract on-chain.
And so it's like a highly secure, verified messenger service for the blockchain.
That's a good way to put it. Removes that central point of failure.
And the scale here is just, it's staggering, isn't it? This isn't some theoretical thing anymore.
Not at all.
I mean, quick stats show Chainlink securing over, $11.3 billion in total value secured, and servicing more than $6.18 trillion of transaction value back in 2022 alone.
Yeah, the numbers are huge.
It's not niche. That's foundational global infrastructure already.
It really is. And that incredible scale, it demands evolution. That's why their whole roadmap, Chainlink 2.0, it really revolves entirely around perfecting this DAWN model, making it even better.
So what's the big advantage of the DAWN? What makes it this architectural leap, not just, an update?
Well, think of a DAWN as a decentralized committee. It's a group of independent node operators, all working together under a consensus protocol.
Okay.
By spreading out the job retrieving data, verifying it across this whole committee, they enable something really powerful. Hybrid smart contracts.
Hybrid smart contract.
Yeah. These are applications that blend the best of both worlds. You get the tamper-proof security of the on-chain code, but also the flexibility and, frankly, the efficiency of off-chain computation that can actually react to real-world events.
Right, so smart contracts aren't blind anymore. They can see and react.
Exactly.
And Chainlink offers some key services built on this. The first one, maybe the most famous one, are the data feeds.
Yeah. Data feeds are absolutely the bedrock, yeah. They fetch that high-quality, real-world information where accuracy is just non-negotiable.
Like prices.
Definitely prices. Crypto token pairs, FX rates, commodity prices, but also more niche stuff now, like NFT floor pricing or even weather data, sports results.
And this is where, you see the reliance. The sources point out that DeFi giants Aave, Synthetics, Compound, they all rely heavily on Chainlink for these price feeds.
They do. It's critical for DeFi.
And Ethereum, which accounts for, 57% of the total value locked in DeFi using these feeds. I mean, if Chainlink secures that much of the ecosystem, how do we avoid just swapping one central failure point for another? Is Chainlink itself the new risk?
That's a really essential question to ask, and the answer lies in the security model. It's not built on trusting, Chainlink Labs, the company.
Okay.
It's built on trusting the math, and crucially, the economic incentives baked into the Decentralized Oracle Network itself. No single entity controls that data stream.
It's the consensus.
It's the consensus of dozens, sometimes hundreds, of independent, geographically distributed nodes. That verifiable decentralization is the defense against it becoming a single point of failure.
Okay, that's a critical distinction. Verifiable decentralization. Got it. Now, moving to something else that absolutely needs security and integrity, the Verifiable Random Function, or VRF.
VRF is fantastic tech. It generates random numbers that are cryptographically truthful. They're tamper-proof and provably fair.
Which is huge if you're running anything like a game or dealing with NFTs, right? You need real, provable randomness.
Absolutely. You need to know that your NFT rarity wasn't manipulated or that the lottery draw wasn't rigged by someone.
Yeah, you don't want someone gaming the system.
Precisely. So VRF gets used for things like determining NFT rarity think projects like Avagachi or Axie Infinity, or ensuring genuine fairness in, say, ticket-based drawings like Ether cards used.
Okay, fair randomness. Now, speaking of connecting things, let's talk about the big one, CCIP. The Cross-Chain Interoperability Protocol. This feels like a whole other level.
It really is. CCIP isn't just about reading data from the outside world. It's about enabling smart contracts to securely talk and transact across entirely different blockchains.
So sending messages and even value between chains.
Exactly. It provides the infrastructure for contracts to communicate safely across these otherwise siloed chains. And what's really fascinating is how it's bridging not just different crypto chains, but also connecting to traditional finance.
You mean like the SWIFT partnership?
That's the big one. Chainlink partnered with SWIFT, the messaging network basically all global banks use, way back in 2016. That collaboration recently led to a proof of concept.
What did it show?
It showed that banks, using their existing SWIFT infrastructure, could securely communicate and send instructions to major blockchains via CCIP. It's a massive bridge.
Wow. So this is potentially how trillions in traditional assets could eventually interact with the decentralized world.
It's a key piece of that puzzle, yeah.
And we're seeing real adoption happening now, right? Wasn't there news just this month, September 2025, about the Saudi Al Bank, SAB?
Yes, exactly. That's a major validation point. SAB announced they're adopting Chainlink's infrastructure, including CCIP, to push forward their on-chain finance initiatives.
What are they looking at specifically?
They're testing things like tokenizing real-world assets, enabling much faster and cheaper international payments. It's all part of Saudi Arabia's Big Vision 2030 plan.
So national-level digital transformation efforts are seeing Chainlink's plumbing as essential.
It seems so. It points to a future of faster, cheaper, safer global finance, potentially enabled by this kind of tech.
Okay, let's shift gears slightly into the Chainlink 2.0 vision. You mentioned Dawn's evolving. Part of that is tackling scaling and security threats more directly, right? You said Dawn's act almost like a layer 2 solution.
Yeah, that's a core part of the design. It's about moving the heavy computational lifting off the main, often slower and more expensive, layer 1 blockchain.
How does it work?
The Dawns use their own efficient committee-based consensus protocols. This lets them achieve much higher performance. We're talking lower latency, lower fees, because the bulk of the computation happens within the Dawn, off the main chain.
And the data supports this.
It does. I mean, while Chainlink is obviously huge on Ethereum and Binance Smart Chain, if you look at faster, cheaper layer 2s like Polygon actually has the largest average market share, about 47%, across cumulative products like Keepers and VRF.
Interesting. So speed and cost clearly drive adoption for those services?
Absolutely. It shows the demand for efficient off-chain computation.
Now, to make that secure, to connect that fast off-chain stuff back to the secure layer 1, they developed something called the Transaction Execution Framework, or TERF. Can you break that down? How does it keep things safe?
Yeah, TERF is clever. Think of it like splitting a contract's job. You have the secure vault, and then you have the quick processing slip. TERF decomposes the smart contract. Part of it stays on the main chain, that's the anchor contract. It's the secure vault handling the actual assets, the final security layer.
Got it.
The other part is the Dawn executable. This runs on the fast, high-performance Dawn, handling all the complex logic and computation quickly and cheaply off-chain.
But the main chain always has the final say over the assets.
Exactly. The main chain anchor contract maintains ultimate control and security over the funds, even while the heavy computation happens much faster elsewhere. Best of both worlds.
Okay, that makes sense. Now, let's tackle probably the biggest, or certainly one of the most talked about, integrity issues in crypto. Front running.
Yeah. Minor extractable value, MEV, front running. It's a huge problem.
Where bots basically see your transaction coming, jump ahead in the queue, and exploit the price movement your transaction will cost, right?
Precisely. They exploit information leakage and ordering control to profit at the expense of regular users. It undermines fairness.
So how does Chainlink address this? They have something called Fair Sequencing Services, FSS.
Yes, FSS is designed specifically to combat this. Think of it as creating a fair waiting room for transactions destined for a smart contract.
How does it enforce fairness?
It provides what's called block order fairness. The key idea is a large majority of the nodes in the DON-C transaction A arrive before transaction B, then FSS guarantees that transaction A must be sequenced either before or at worst in the same block as transaction B when it finally hits the main chain.
So it prevents miners or arbitrage bots from just reordering things however they want to maximize their profit.
Exactly. It preserves the integrity of the arrival order, stopping that kind of exploitative reordering. It makes the queue fair.
That seems incredibly important for DeFi especially.
It's absolutely critical.
Okay, now let's talk privacy. We're pulling in potentially sensitive off-chain data.
Yeah.
How does Chainlink handle confidentiality? How do you prove something without revealing everything?
Right, another crucial area. They basically have a dual strategy here. The first approach is called DECO. Yeah, it's a clever cryptographic protocol. It allows an Oracle node to essentially prove statements about data it got from a standard HTTPS web server, but without revealing the underlying raw data itself.
And the clever part.
The really clever part is that DECO doesn't require any changes on the server side. The website or API you're querying doesn't need special modifications. It uses advanced cryptography, zero-knowledge proofs, basically, to attest to the data's properties confidentially.
Okay, no server changes needed. That's powerful. And the second approach, you mentioned Town Crier.
Town Crier is the other main technology they've developed. This one is more hardware-focused. It relies on using a trusted execution environment, or T.
A T, that's like a secure enclave within the processor, right?
Exactly. It's a hardware-isolated, secure area where computations can run protected from the rest of the system, ensuring confidentiality even from the node operator themselves.
So DECO is crypto-based, Town Crier is hardware-based.
Right. And combining these allows for some really interesting applications, like they've discussed things called mixicles.
The mixicles sounds fun.
Yeah. They're basically confidentiality-preserving DeFi instruments. Imagine a financial contract backed by some specific asset, but you don't want to reveal what that asset is publicly on the blockchain.
Okay.
A mixicle, using these privacy techniques, could just reveal a simple binary switch value, like condition met or condition not met, to the smart contract without revealing the sensitive underlying details. Preserves privacy for certain financial strategies.
Interesting. So privacy is handled. Now, wrapping up the security picture, what are the sort of ultimate safety nets, the trust minimization guardrails?
Good question. They have a couple of layers. One is literally called guardrails.
Okay.
These are basically preset logic checks that live on the main chain itself, associated with the contract using Oracle. They monitor the Oracle's output.
For what?
For anomalous conditions. Like, imagine a price feed suddenly reports a price that's wildly different from the last few updates, like a 90% drop in a second. The guardrail could detect that anomaly and automatically pause the smart contract's execution.
Acting like a circuit breaker.
Exactly, a safety switch triggered by unexpected Oracle behavior. And then there are also minority reports.
Minority reports. Like in the movie.
Maybe inspired by it. The idea is that even if a majority of nodes in a DON somehow get compromised or collude to report bad data, a small fraction of honest nodes observing this malicious behavior can still issue a minority report flag to the main chain. It serves as a warning signal that something is wrong with the supposed consensus.
So even if the majority is compromised, the honest minority still has a voice.
Precisely. The main chain always remains the ultimate arbiter, the final source of truth and safety control.
Okay, that paints a pretty robust security picture. Let's switch to the economics that power all this, the engine room, so to speak. It all hinges on the Link token, right?
Yes, the Link token is central to the economic model. It's an ERC-677 token, which is like an ERC-20, but with some added functionality.
And its primary role?
Its main job is to be the medium of exchange. Node operators, the ones running the infrastructure and fetching the data, get paid in Link Pay for their services by the smart contracts requesting the data.
Standard payment token.
Right. But maybe even more importantly, node operators also have to stake Link Pay. They deposit it as collateral.
Why? As a security deposit.
Exactly. It acts as a guarantee for their data delivery and, crucially, for their honest behavior. If they provide bad data or fail to deliver, their staked Link can be taken away.
Okay, skin in the game. Now, this brings us to something I found really fascinating in the white paper. This concept of superlinear staking impact. Forget the exact formula for a moment. What's the core idea? How does it defend the network?
It's a really elegant piece of crypto economic design. The fundamental insight is this: the cost for an attacker to successfully corrupt the Oracle network grows much, much faster than the amount of value they're trying to secure or bribe.
Fast back.
Well, in a typical system, if you want to bribe, say, N voters or nodes, your required budget just grows linearly with N. Double the nodes, double the bribe cost, roughly.
Makes sense.
But Chainlink's model, because of how it concentrates the rewards for catching a bad actor and slashing their stake, means the attacker's required budget grows super linearly, potentially quadratically, like N squared.
Whoa, okay, so bribing doesn't scale well for the attacker.
Not at all. It quickly becomes economically irrational, prohibitively expensive to try and bribe a majority of the nodes, even if the individual stakes aren't astronomically high. The cost structure itself defends the network.
So the incentive to just be honest and earn fees is massively reinforced by the sheer escalating cost of trying to cheat the system.
Exactly right. The economics strongly favor honesty. And there's another layer to this incentive structure, too, beyond the explicit staked aim.
What's that?
It's called future fee opportunity, or FO.
Future fee opportunity.
Yeah. Think of it as the estimated present value of all the future earnings a reputable, reliable node operator expects to make by continuing to provide good service.
Ah, so their reputation and future business prospects.
Precisely. If a node operator misbehaves, they don't just risk losing their current stake, they risk destroying their reputation and losing all that potential future income, the FFO. It acts like a huge implicit stake that further incentivizes them to play by the rules.
Okay, so you have the explicit stake, LINK, and the implicit stake, FFO, both secured by this superlinear cost of attack.
Correct. And when you combine superlinear staking with FFO, you get what they call the virtuous cycle of economic security.
The virtuous cycle. How does that loop work?
It's a positive feedback loop. It starts with users paying fees for Oracle services. More usage means more fees paid to the nodes.
Right.
These increased fees allow nodes to stake more or attract more stakers, which directly increases the overall crypto economic security of the network. It makes that superlinear cost of attack even higher.
Okay, more use, more security.
Exactly. But then this increased security actually leads to economies of scale. The cost per dollar of value being secured by the network goes down. It becomes more efficient.
Cheaper security encourages more people to use it.
Precisely. Lower costs and higher trust stimulate more demand for Oracle services. More demand means more fees generated, which starts the cycle all over again, boosting security further, reducing costs, driving more demand.
More use, more fees, more security, lower cost per dollar secured, more demand, more use. Wow, that's powerful.
It's designed to be a self-reinforcing system where success breeds more success and more security.
Okay, finally, let's put some faces to this massive infrastructure project. Building something that's foundational takes serious long-term commitment. Who are the key people?
Well, you have to start with the CEO, Sergey Nazarov. What's often missed is just how long he's been thinking about these problems. He was involved in peer-to-peer tech way back in 2009.
Over a decade before Chainlink's mainnet launch.
Yeah. He co-founded SmartContract, which was basically the initial Chainlink prototype back in 2014. And interestingly, his background isn't purely technical. He studied philosophy and management at NYU. He's been focused on this specific Oracle problem for a very long time.
That long-term focus is key. And the co-founder, Steve Ellis.
Steve Ellis, yeah. He's got the computer science background, also from NYU. He co-founded Secure Asset Exchange and then SmartContract right alongside Nazarov.
So they have a history of building together.
They do. That shared history, building ventures together before Chainlink, likely gives them that crucial long-term perspective needed for designing robust, secure architecture that needs to last.
And then there's a very big name involved as a strategic advisor, Eric Schmidt.
Right. The former CEO and chairman of Google, later Alphabet.
What's the significance of having someone like Schmidt advising Chainlink? It's not your typical crypto advisor.
Well, it brings instant, serious credibility, obviously. But more than that, it brings unparalleled expertise in scaling technology to a truly global, massive scale.
He helped build the internet as we know it.
Pretty much. Schmidt was a driving force behind scaling Google and the traditional internet infrastructure to handle billions of users worldwide. His involvement signals that Chainlink sees its mission not just as, a niche crypto solution, but as building the foundational infrastructure for the next evolution of the internet and internet value. Schmidt knows what it takes to build reliable global scale systems.
Okay, so we've got this comprehensive picture. Chainlink as this vital, secure, middleware. It connects those rigid, isolated blockchains to the messy, dynamic real world. It's driven by these key innovations like Dawn's FSS for fairness and this superlinear economic security model.
That's a great summary. And looking forward, perhaps the biggest implication, building on everything we've discussed, might lie in those confidentiality tools we talked about, Deco and Town Crier.
The privacy tech, how so?
Well, they potentially unlock one of the holy grails of DeFi, supporting under-collateralized loans in a secure way.
Wait, loans where you don't have to lock up more value than you borrow? That sounds risky in a trustless environment. How would that work without full transparency?
That's exactly the challenge, and where privacy tech comes in. It's about bridging traditional finance risk assessment with decentralized privacy principles. Imagine a borrower needing a loan.
Okay.
Instead of revealing their entire financial history on-chain, they could use Deco, or a simile technique, to generate a high-assurance, confidentiality-preserving credential. This credential would cryptographically prove that, say, their credit score is above a certain threshold, maybe 750, or that their income meets certain requirements.
But without revealing the actual score or income figures to the public blockchain, or even the smart contract itself.
Precisely. The smart contract just receives proof. Condition met. Yes, no. It verifies the borrower's creditworthiness based on off-chain data without compromising the borrower's data privacy.
The ability to privately verify creditworthiness.
Yeah.
Anchoring traditional risk checks into a trustless, decentralized system, but keeping the sensitive data private. Wow.
It could be a pathway to bringing much more real-world lending and capital efficiency into DeFi, moving beyond the current over-collateralization requirements.
That really is a powerful closing thought on where this could all be heading. Bridging worlds securely and privately. Thank you for walking us through this deep dive.
My pleasure. It was great discussing it.
And to you, our listener, thank you for joining us. We really encourage you to think about the immense implications here. What does it truly mean when our trustless financial systems can securely connect with, understand, and utilize the verifiable data of the entire real world? Lots to ponder. Until next time.